Differentiation and integration is belongs to your unit 4, and you have to learn this differentiation using the Newton's forward difference interpolating polynomial and Newton's backward difference interpolating polynomial. These are the two main interpolating polynomial we can use for finding the differentiation and integration also. Now, what do you mean by differentiation? Suppose a function y equal to f of x is given by a table of values xi, yi. The process of computing the derivative dy upon dx from some particular values of x is called numerical differentiation. Similarly, when we will go or when I will explain you the integration, on that time I will explain you the definition of numerical integration. Here it is clear that the process of computing the derivative dy upon dx, d2y upon dx square, these are the numerical differentiation. Now, because we have considered here using Newton's forward difference formula, so we have to take the Newton's forward difference formula. Newton's forward difference formula is yx equal to y0 plus p delta y0 plus p into p minus 1 upon 2 factorial delta square y0 p into p minus 1 p minus 2 upon 3 factorial delta q y0. Accordingly, we can expand this formula according to our questions. Now let us take this one is your equation number 1. Now here p equal to x minus x0 upon h, or you can write here x equal to x0 plus ph. Now let us differentiate equation 1 with respect to p. So when I will differentiate equation 1 with respect to p, so the left hand side becomes dy upon dp. So dy upon dp equal to del y naught, and differentiate of this one equal to 2p minus 1 upon 2 factorial del square y naught p into p minus 1 p minus 2 upon 3 factorial. If you will differentiate this one, that becomes 3p square minus 6p plus 2 divided by 3 factorial to delta qi0. Similarly, if I will take another terms, that is p into p minus 1 p minus 2 p minus 3 divided by 4 factorial delta fourth y naught. So that is the derivative of that fourth order terms. Now let us take again, this one is your equation number 3. Now differentiate equation 2. Equation 2 को differentiate अभी करेंगे. So equating and differentiating equation 2 with respect to x, we have dp upon dx equal to 1 by h. Now our motto is to find out dy upon dx. So dy upon dp into dp upon dx. ये इक्वेशन 1, इक्वेशन 3 में हम लोग dy upon dp we have derived, and in here we can find dp upon dx. If I will multiply these two, 1 by h I have written here, del y naught 2p minus 1 upon 2 factorial delta square y naught plus 3p square 6p minus 2 divided by 3 factorial delta qi naught. So here also we can write this one. Now this one is called your derivative with respect to s at x equal to x0 plus ph. Now, so when x equal to x naught, suppose if you write here, x equal to x0, and if x equal to x naught, so we know that x equal to x0 plus ph. So here if I will take x equal to x0, then definitely p equal to 0. So in case of p equal to 0, so this equation becomes, let us see this equation. Here we have to put p equal to 0, that means x equal to x0. So all the p terms are 0. So if all the p terms are 0, then dy upon dx at x equal to x naught, that becomes 1 by h, that p becomes 0, delta y naught half into delta square y naught 1 by 3 delta qy naught minus 1 by 4 delta fourth y naught, like this you will find here. And this is called the first order derivative at x equal to x0, and this is called your first order derivative at x equal to x0 plus ph. Now again you have to find the higher order derivative also. So in case of your higher order derivative, that means you have to find d2y upon dx square. d2y upon dx square equal to d upon dp dy upon dx into dp upon dx. So exactly what is happening here. So here d upon dp of dy upon dx into dp upon dx. So dp upon dx equal to 1 by h, that we have written here. Then derivative of dy upon dx with respect to p. Whatever the derivative we have already find in case of your dy upon dx, that we have to differentiate again with respect to p. Now let us differentiate again. d2y upon dx square equal to 1 by h square, another h that initially we have already find 1 by h, and this one is again 1 by h square. So del square y naught, that is the first term, p minus 1 del q y naught plus 6p square minus 18p plus 11 by 12 delta fourth y naught, like this you have to find here. And this one is the derivative at x equal to x0 plus ph. That means this one is x equal to x0 plus ph. Now when x equal to x naught means p equal to 0. So you have to write here p equal to 0. Then when I will write here p equal to 0, that becomes d square y upon dx square at x equal to x0 equal to 1 by h square del square y naught minus del q y naught plus 11 by 12 delta fourth y naught. And this one is called your second order derivative. And this one is maximum times used for finding the acceleration, gravity. So in that case, we have to use the derivative terms. We know that Newton's forward difference formula generally used when the interpolating point is nearer to your initial point. So if the derivative also asks nearer to your initial point, then we have to use these formulas for finding the derivative. Now if the derivative point, that means the interpolating point is nearer to your end points, then on that case we have to use the Newton's backward difference formula. The procedure is same as usual, but here we have to use the Newton's backward difference interpolating polynomials. So let us consider Newton's backward difference interpolating polynomial. So yp equal to yn plus p delta yn. This is called your Newton's backward difference interpolating polynomial. In case of forward, here p into p minus 1 upon 2 factorial delta square y naught. This is the reverse delta they have written here. Similarly, in case of p, x minus end point, x minus xn divided by h. So again, we have to follow the same procedure. dy upon dx equal to dy upon dx equal to dy upon dp into dp upon dx. So dp upon dx means dp upon dx equal to 1 by h, and dy upon dp, you have to differentiate this one with respect to p. Then when I will differentiate this one with respect to p, then we are getting this one. Now this formula is applicable when x equal to xn plus ph, and this is only true when x equal to xn plus ph. Now xn plus ph, when we will take this derivative, we can use. Now if x equal to xn means p equal to 0, so here, so you have to write p equal to, you have to write p equal to 0. So p equal to 0 means that becomes 1 by 2, and this one as it is you have written, and p equal to 0 means 1 by 2 del square yn. Then here p equal to 0, this p equal to 0, 2 by 6, 1 by 3 del q yn, like this. Now again when I will find the second derivative, so in case of second derivative also, we know that d square y upon dx square equal to d upon dp into dy upon dx into dp upon dx. So dp upon dx equal to 1 by h. We have already know. So again, we have to differentiate dy upon dx with respect to p, so that we can find d square y upon dx square. Now, difference d square y upon dx square equal to this 1 by h I already written, and another 1 by h is there. Then these two multiplied by 1 by h square, and the first term, this one becomes 0, this one becomes 0, and del square yn is the first term into del square yn. P, here you have to differentiate again, p plus 1 divided by 2, that is your del q yn. This term, this one you have to find here. Similarly, fourth order term you have to find here, and this one is called the second order derivative. Again, this one is we can use when x equal to xn plus ph. Now when x equal to xn, that p, again the p becomes 0, and in place of all the p's we have to write 0. So when p equal to 0, d2y upon dx square equal to 1 by h square, this one. So this one is called the higher order derivative in case of backward difference formula. In the next video, so I will explain you one problem taking into Newton's forward difference interpolative polynomial and Newton's backward difference interpolative polynomial, both for finding the first order, second order or higher order derivatives.